Hello, and welcome to this course in which we're talking about the use of Python and decoys for active defense. In this video, we're going to talk about the use of decoy processes for active defense. So, decoy processes are one of the active defense techniques that can be applied in a wide variety of different ways. Running processes on the system can be used to cause an attacker to target applications that pretend to be vulnerable and aren't, can be used to attack the defenses of the system, etc. In this video, we're going to be looking at a decoy process that could potentially pretend to be a legitimate antivirus on the system or part of a system's legitimate defenses against attack. And so, if so, it would not be surprising for malware to target this process and attempt to eliminate it as part of an attempt to ensure that the malware is capable of running on the system. Alternatively, the malware might scan for processes running on the system, detect this one, and elect not to run for fear of being detected and removed from the system. And so let's take a look at the code we'll be using for this particular demo. It's called decoyprocess.py, and if we open it up, this is a relatively short Python program. And the reason why is that all it's designed to do is run and then notify the system administrator or security team if it has been terminated. And so to accomplish this, we're going to be using the signal library in Python, which allows us to catch and gracefully respond to signals that are sent to our process. And so how we're doing so is we've got a function definition here called terminated that doesn't really do much of anything. All it says is pass, and it's just designed to allow us to call signal.signal to catch certain signals that are sent to our process. And so there are a few different ways to terminate a process on Linux. So there's sigterm, sigint, and sigkill. And so the sigterm and sigint signals that could be sent to a process are ones that actually are catchable. And so these are things like if you hit Control-C to kill a program that's running, it can actually catch that signal, meaning that it doesn't have to immediately terminate like it theoretically should. The reason why you're able to catch these types of signals is it allows the process to clean up itself up gracefully. So for example, if it needs to finish writing some data that's stored in a buffer to a file or clean up temporary files, etc., it can do so and then terminate gracefully rather than being potentially left in an unstable state. And so we can take advantage of this ability to catch sigterm and sigint, because if another process running on the system sends these signals to us, we can record which process actually did so. Now, how we can do this is by calling signal.signal, specifying the signal that we're catching, and then calling our terminated function, which again does nothing. These lines of code and our function up here are just designed to allow us to catch a signal rather than responding properly to it. Now, notice here that we do not have sigkill listed here. And the reason for that is that sigkill is an uncatchable signal. We can't do anything about it. We can't catch it and respond. It's essentially a hard shutdown for the process, which means it's something that we can't protect against in this particular case. And so beyond catching these signals, we also want to collect information that would be useful to a system administrator or security team. And we're handling that here with our while true loop. So while true our system is going to just continue running. And we're going to use signal.sigWaitInfo to essentially wait until we receive a particular signal. In this case, we're going to attempt to respond if we receive a SIGINT or a SIGTERM signal. And so these are the types that we're catching up here. And so if a SIGINT or a SIGTERM is sent to this process that we're running, we're going to store certain information about that signal in this variable SIGInfo. And one of these pieces of information is the process ID of the process that terminated our function. And so if we catch a signal to ourselves, we're going to open a file called terminated.txt and write to it. And then what we're going to write is process terminated by, and then a %d here, which if we look over here is going to be siginfo.sipid, which is the process identifier of the process that sent that SIGINT or SIGTERM. And then after we've received that, we're going to call exit0 to terminate this process. And so from the attacker's perspective, they pretty much get exactly what they want. When we get sent SIGINT or SIGTERM, it's going to cause the process to terminate. However, before our process terminates, it's going to exit gracefully, meaning that it has the opportunity to take additional actions. In this case, it allows us to write information about the terminating process to terminated.txt. And this could easily be modified to send an alert via syslog or something to a security team saying this process has terminated our, call it a decoy antivirus. And so this is probably the act of a malicious process, and so actions should be taken to investigate and potentially remediate the potential infection on the system. And so now let's see this in action. So I'm going to close this out and run it with python decoy process.py. And so it's just running along here. In our other window, we need to find out what our process ID is so that we're able to kill it. So if we use process ps-al, we see that Python 3 is the process actually running decoy process here. And so we've got a PID of 2463. So what we can do is send a kill command, send -2 so that it's a non-fatal kill, and then specify the process ID that we want to terminate, 2463. We hit enter, and we see that our process has terminated over here. However, if we cat terminated.txt, we see that we've successfully printed that process 2348 was the one that terminated us. And so this information could allow us to investigate, in this particular case, since it's not a process so much as the user killing it, this might not be a sign of an active malware infection. However, the fact that someone has murdered our decoy antivirus could mean that this SSH session on the computer is used by a malicious party. Or it could be a benign user that for some reason decided to kill the fake antivirus, but still probably warrants investigation. And so this sort of code works better on Linux than Windows because of Windows' implementation of the various available signals. It's much harder to effectively catch a signal and gather information about it on Windows. However, we could take a different approach to implementing the same functionality on Windows. Rather than attempting to detect inside a process the fact that a particular process, that the process has been killed, we could make a simple detection scheme that just looks for the fact that a particular process is not running. We could even build it into the process itself, where via registry auto run or scheduled tasks, we attempt to run the process, see if another instance is running. If so, nobody's tried to kill it. If not, it has been killed. We could also monitor a system with a secondary process to look for those attempted terminations constantly, and also to monitor for processes that might try to identify the processes running on a system and potentially terminate shortly afterward, which could be malware that detects an antivirus and elects not to run at that time so that it can't be detected and remediated on the system. This is one demonstration of how we can take advantage of signal handling and monitoring processes to use a decoy process as a fake antivirus to detect malware that attempts to interact with that fake antivirus in some way. Thank you.